Remember Titanic, don't we? In biblical times, men were used as warning scouts to watch out for danger.
Fucking me!
This is what happened when men were in charge of a machine replacing men and giving caution for the danger ahead.
What does radar stands for? Radio detection and ranging. Right, standing and shouting over a cliff. You hear it multiple times. That's echo, right? So, using the speed of sound, we can calculate the time it takes to come back bouncing from the object, and distance can be calculated.
This type of radar is echo radar, which works on the principle of echo. It uses sound and radio waves to determine the position of objects. It was majorly used during the World War.
Let's see how the technology works. Radar works by sending short pulses of electromagnetic energy in the form of radio waves outwards. The antenna then switches to receiver mode and waits to detect the reflections of these radio waves off distant objects. The radar now receives a blip on the screen called a radar cross-section, and its size changes with the magnitude of radio waves returning to the antenna. The radar cross-section is a measure of how detectable an object is with radar. The size of the object is just one factor, which can be mitigated with clever engineering.
Second type of radars are Doppler radars. They are used by keeping EM wave shift position and form into account while transmitting them. The shift while receiving is observed carefully. For a positive shift, the object is moving towards, while for a negative shift, it is moving away.
For the first time in 1935, Sir Robert Watson Watt and Sir Arnold Wilkins gave the idea to use radars to detect planes.
Few of the first radars looked like this.
The Smart L EWC is a state-of-the-art radar system with the ability to detect targets at extreme distances. Its excellent features make it possible to detect stealth threats and ballistic missiles from launch up to impact.
With the advancing technology, radars can now be installed over ships. See, the hemispherical region shown is the area covered by radar. The area is rather less but is extremely useful during war or navigation in the sea. It can detect flying as well as underwater objects. During threats, the automatic threat eradicating systems can be used to mobilize and destroy the threats and save many lives.
Application of radars, weather reporting, detection of flying objects, detection of underwater objects, detection of flaws in finished products.
Everything has its limits. The B-2 stealth aircraft is well known worldwide for its ability to trick radars and bomb enemy targets without leaving any hint. It is made up of special stealth material.
From the early years of world wars, the radar has developed a lot in its domain. To cope up with the advanced radar technology, stealth aircrafts were built.
The B-2 has a 52-meter wingspan, yet it has been reported to have the same radar cross-section as a large bird. So how does the B-2 manage to achieve this incredible feat? The core concept behind the B-2 is reflection. It was designed to reflect the radio waves away from the source, so that they never get the chance to be detected. What is amazing is that every surface of the B-2 has been designed with this in mind. The aircraft was designed with the aid of computational models and a supercomputer, which resulted in an incredibly complex curved shape.
So while being mid-air, it is like B2 is wearing the invisibility cloak from Harry Potter and is invisible to the radars around. Pretty cool, huh?